Good evening, everyone. So let's talk about AI thinking, training, and memory. I will cover two thinking patterns, and then they're trained based on data, right, which can also be called memory, and five different kinds of memory. And within this, I'll also cover the training process of it. So this is like going to be a very simplified, condensed kids version of all these complex terms that I was going through over the last few months because we're also building our own AI systems. So I think this is all you need to know to pretty much get started when you're building your own AIs, or you're trying to understand AIs, or just out of general knowledge or whatever reason you have, right? So let's start with the outputs and the thinking that generates those outputs, right? So there are two kinds of thinking that AI can do. There is the deterministic thinking, which is you give it a fixed data and it only generates data from it. That is deterministic. It is predetermined. This is like the first form of thinking, kind of thinking, all right? So this might be more evident in hospitals where you don't want the AI to hallucinate or come up with these random variables. This might be true for AI systems that you're building for, I don't know, like these really like self-driving cars or like these really specific systems and softwares where you don't want the AI to have any flexibility. You don't want it to evolve, to come up with to have like these random systems there. And you just wanted to use the data and the knowledge that you provided it and only generate answers or, um, well, not all AIs are chatbots on that note. So only generate actions or whatever, if it's an agent or something, from the core data that you have given it, and you don't want it to do anything else. That's deterministic, a predetermined data set that is used to generate answers. Then on the other hand of the spectrum, we have dynamic or adaptable thinking, in which AI can self-evolve, or at least come sort of close to that in sort of a interaction way, right? There are lots of different ways of implementing this. There's obviously human feedback. You can give thumbs up, thumbs down. There's self-evolving AIs. They have so many different thinking frameworks inside them that it will look at different patterns every single time. It will read different informations. It might hallucinate even, which is very common. So this is what is common in large language models, right? Because an AI's capacity to be intelligent is restricted if you only contain it to predetermined rules and deterministic data. That's where dynamic comes into play, where you can set frameworks, and this could be called, they're like different terms for this, RAG or whatever, or thinking architectures on the data set. And you have a really large data set, and you have like other things that you can basically add on top of it. And by data, I mean like, let's suppose we have 1,000 books, whatever, right? But this is true for large language models. They generally have like a lot more data that they are trained on. And they can also match patterns and hallucinate, which is very common. But that allows the AI to generate unique answers and give you or come up with new reasoning and things that might not have been um, there before, right? So like it can match patterns and it can match patterns across different datas or whatever. So that's like the dynamic side of things, kind of artificially stimulates how a human functions. Not exactly there. It makes up for the lack of its ability for creative thinking or whatever with having large amounts of pattern um, that they match things based on. Now, to execute both deterministic and dynamic, and to train the models to think dynamically or deterministically, you need memory, right? And then you obviously use that memory to train the model. And there are five different kinds of memories. And I'm going to simplify this again in terms of the outputs that it's going to generate. So, first one, let's start with deterministic. Most smarter or modern day LLMs start in some, they're like hybrids. They start with some deterministic way before leading into dynamic or adaptable learning. So you start at um, core foundational data set. Call this like, or core foundational memory. Okay. This is like the foundational training resources, everything that you use to initially train the model. So this is like all um, like let's suppose I'm training a business AI. So I can scrape online all the public podcasts I can find on business by Alex Ramosi or a bunch of these guys. Or I find all the books that are available on business and I find all of these different things. Um, and then I use that as the foundational knowledge to train the AI on it. Now I know there are LLMs and they are local hosted, which are you can use from open source models, but we're not going to get into that. This is me simplifying things really well for beginners. So let's suppose I take 1,000 books. Now the AI is going to use those 1,000 books and generate information and data from it, right? That's my core foundational data. Cool. So that's like the first form of memory, which is like the initial data set that you would use for AI to generate answers from. Then you have RLHF and the memory bank that uses RLHF, and RLHF is another form of training pretty much. So you would use the predetermined data set coming back to the previous one, the core foundational knowledge and training data or the foundational memory using a form of RAG, which is called retrieval augmented generation, where the AI or an LLM uses a certain way to retrieve information from that. Like that's just forget our RAG. Just think about like it's using that data, right? So that's like one form of training, which is RAG. I mean, RAG kind of goes everywhere. This is like a basic version. Then you have next one, which is RLHF, which is reinforced learning through human feedback. Does that sound weird? It's not. So this is where you have your foundational data. And this is something that these AIs, and this is what is often forgotten. Or you can like sign like in the developer space, they call this fine tuning or different terms for this. But anyways, so like all these large language models have had massive amounts of fine tuning or RLHF, human feedback done um, to them in supervised environments before it was shipped out. Like, how do you think the AI is not giving you these NSFW responses or not making these really negative or extreme generations? That's because previously it was doing that and humans were telling it that's wrong, don't do it, right? So, and then obviously all of that data and memory gets stored as well. So there is a memory that gets generated through supervised human feedback. And you train the AI by getting it to generate output. And a simple way of doing that, you can score the responses, or you can give yes and no or whatever. But like, so I can get like, let's suppose I make a chatbot, and I ask it to give me 5 responses, right? And I tell it out of these fives for the same question, which one is better? And you keep on doing that until it starts like the level of output is really decent. So that's like reinforced human learning. This is important because you might, and me being slightly advanced here, so you might give your AI a training data set initially, but there's no guarantee that it's going to retrieve the same information every single time. LLMs, especially if you're using an API or an open source LLM, because you're not going to train an AI from scratch. It's like too expensive. It's can't be done by you. All those things. You're likely going to either use an open source model to host this locally, which means you're going to run it through your own GPUs or something, which might be for a small scale. Or you would use a lot, like you would use ChatGPT or like OpenAI or Claude or whatever, and use their API or mask it. Um, and then use those in the backend to generate whatever reasoning or outputs you're doing, right? Now, most of these large language models have already done all the human feedback then. We do another layer of it, so the reasoning or the outputs are more tailored to the kind of answers we want. So for example, if I only wanted to give me answers in context of business, then the AI, then the feedback I'm going to give it, or if I have a specific style of generation. And so you're going to basically do it that way, right? So that's RLHF. On that note, Scale AI, this Alexander Wong's company, or a bunch of these really large companies, they used to hire outsourced workers in Kenya or these countries and pay them like $1 or whatever, thousands of them. And all day they would simply train the data. That's like all they were doing. They were like getting responses, telling which one is good, which one is bad, manually basically scoring data. And that's how, like, some pretty graphic stuff. But and some pretty like random shitty responses because these guys are taking care of all the random AI slop before you see the polished version, right? So it does happen. And we can do another layer of that. So that covers the second form of training and memory. Let's move on to the third one. This one I'm going to, and we're still kind of in the supervised deterministic side. We haven't gotten into the self-evolutionary phase yet. All right, so that's going to happen next. But this one is for personalization. The third form, I'm just going to call it user memory. All right. So do you ever go to ChatGPT and it remembers conversations that you had previously, or it can save memories and all those things, or it can personalize responses to you? Um, we're just going to call that user memory. Now, depending on how complex of a system you're building, you might not need user memory. But this is just like if I'm using the AI, I wanted to start building a memory and taking data of the responses and my preferences and my personal information, like my name is Varys and I work here, and you know, and even if you're being a little dark with this, you can ask it, like you can get it to predict personality profiles and all those things, so it can customize and personalize responses to you. Um, but all of that is user memory. So that's like the user who's using it. It's just personalized to them. It's like a specific memory that is just for that user. Um, and then we are going to move on to the fourth type. And finally, we are starting to get into the dynamic learning. Um, this is going to be unsupervised user feedback. Let's just put it that way, right? This is like, when OpenAI was made to the public, one of the reasons why it was able to scale so much is because you see those thumbs up, thumbs down versions and your ability to give feedback and stuff like that. Um, now, OpenAI wasn't doing this in real time, but some applications do, some LLMs do. But what it can enable it to do is that, I mean, it also uses that for your personalization. Anyways, sorry. Um, so user feedback is, let's suppose I launched this huge LLM, like when it came, ChatGPT came initially, it had thousands of users. Now every single user was giving it feedback, like, don't make it like this, make it like this. It was giving a thumbs down, thumbs down. It was recorrecting, pointing out the mistakes and stuff like that, right? So that's like user feedback on what sort of answers are good, what sort of answers should be generated, um, or you should generate in general. And then the AI can basically use that data to reset new rules, set new thinking inferencing patterns, set new architecture on its own, slightly advanced. Dynamic is advanced, right? And it can use that to essentially give better outputs on its own. So this is like the self-evolving phase where based on the user interaction, the AI can keep on getting smarter and change and alter its reasoning to get better and better, because you might be constrained by how many developers can reinforce every single kind of outputs. But if you make it public to users, they do that automatically by default, right? So this is like the kind of the fourth way. Now, adaptable or dynamic memory learning, all of these things, training, they have a lot of different things in it. So what I just covered is one way of doing that. Another one is this is like um, I think this is RLAIF. So that's the term used for this, which is those reasoning models. Basically, you can have multiple LLM agents where they critique the answers in the backend. There are different ways of doing this as well. You can create a memory or a training AI alone. So let's suppose you have multiple agents or tools that are giving responses. You can get a smarter AI, which is more expensive, right? Now you might not be able to use, so let's suppose you're having an app and you're using an API, or like let's suppose I have Claude, I have Grok, I have OpenAI's ChatGPT 5 or whatever, and I have like Google's Gemini 2.0 or whatever different models they have. Now different models consume different um, amount of tokens, so they cost more or less, right? That's pretty simple. You take the smarter models, and because you can't make the smarter model more public, because then the cost of running the app is going to be really high, but you still want that model to do something because it's very smart. You can make it the reasoning model in the sense, not the reasoning, like AI supervision model. It can simulate in the backend, and you can build like a system that can do that on its own. Slightly complex, but self-fulfilling knowledge graphs or whatever. But you can essentially take that smarter AI model and get it to critique the outputs. Sorry, give me a second. sorry, get it to critique the outputs of all the responses that are being generated by your base model. So it can condition it and train it to give better responses. So instead of humans giving the feedback and scoring the answers, now you have a smarter AI doing it. So AI is monitoring AI to become better, right? You have a more expensive or smarter or better AI that is monitoring and scoring the responses of your comparatively not as smart AI and telling it what to do, what not to do. And because it's just like it's going to retrieve data every single time. So that's what's going to happen. So it's going to basically give you better responses. Again, with dynamic learning, there are lots of different ways of doing this. Um, this is just like one way. And now coming on to the fifth one, and I don't think like I should like this is more specific. So let me see how we should explain the fifth one. Let's just call this one tool specific memory. So what does tool specific memory do? Great question. It is the memory data that is specific to a tool. So let's try to explain this. Have you seen these in ChatGPT? They have custom agents like Humanizer or image creator or like, all these resume writer or whatever, like these really custom agents and tools. The thing is, the foundational knowledge that we mentioned, that could be like thousands upon thousands of books or whatever size you want. But if you are also creating specialized agents or tools on which are very specific to a certain function or something like that, which is very common, right? For example, like if I build a AI app that has like let's suppose I build a marketing app and one of the tools is offer generator. Its role is to generate offers for me. Now, obviously, in the back end, I can upload like, and this, and it's like one tool is offer generator, one tool is ad copy generator, one tool is um, like staff hiring strategist, one tool is sales specialist. So, like, I'm building these different tools. There could be chatbots, there could be fixed function-based ones where you give an input, it creates an output on cards or something. But what we also should do is have a localized memory of the data that that specific tool should use when it's giving answers. So, for example, for the offer generator, I can upload Alex Hormozzi's 100 million money models or 100 million offers, or scrape down these offer specialized books and podcasts and knowledge and whatever, and use that as the data for the offer generation tool, so that every single time it's not going through like all those thousands of books to generate the response, right? It can first look into the core data and then look into the overall data, and then give an response. So for the ad copy generator, we can upload the ad copy specialized data set. For the sales, we can upload the sales specialized data set, right? Um, and you would quite often have to do this because very rarely we just have one model or one feature. So this is like a way of segmenting memory on top of each other. Now, why this helps when you're building SaaS apps or platforms which have different tools. So this is probably one of the more useful feature. You can give it examples, like you can give the tool examples of different industries, what offer is better in what industry and stuff like that, right? Um, Master prompt is like a very random way of doing this. Very easier way of doing this if you don't want to upload data sets. So you just give it a framework to use when it's retrieving knowledge in like one prompt. But like pretend you are an offer specialist. That's like specialized, that's just like a prompt. I won't call that training or memory. This is slightly more advanced than that, where you actually build a special or a custom data set for that one. But anyways, so if you're building an AI, and let's suppose you're building a complex AI with multiple elements, I would ideally want to have all five of these, right? At least to start off with. So you would ideally have a foundational data that it could use to generate information. So it's like it has context and you're not just randomly using ChatGPT, right? Or whatever AI you have. You obviously have human feedback. So you've hopefully before releasing the app done some form of training and scoring. You don't need to do this at a larger level. I just wanted to cover it. So like supervised in developer setting before you make the app public, you don't just release it. You also get it to generate responses and tell it what's good, what's bad. So you get more of the good ones and less of the bad ones. Right. Third is user memory. So the users that are using it, you want their personalized data, their personality profiles, core data, names, whatever things, basic business profiles or details that will be useful, tailored to your app to also be stored. A fourth one is obviously adaptable ones, and this one can have a lot of things inside it, but adaptable dynamic memory where the AI can self-evolve or adapt or come up with better responses on its own. And then final one is tool-specific one. So congratulations, we covered deterministic and dynamic learning thinking. We also covered the different kinds of memory that can attribute to us making that happen. And with that, we're going to end this video.